Hello, this is the luckiest maths teacher in the world. Thank you so much for watching. Today we go through how to use a table of values to graph a linear function. So firstly, let's take a step back and look at equations that you've already seen. So let's say I have an equation like, 2x plus 1 equals 7. So this is an equation you would have seen ones like this many times. It's an equation because it has an equal sign. And you probably know how to solve this by now, and you know that the solution is just x equals 3, right? So I haven't told you anything groundbreaking at the moment, but I want to illustrate the difference between this kind of equation and the ones we're going to graph. So this equation here is a linear equation, it turns out. So it has one and only one solution, and the reason for that is because there is only one variable. The variable is the letter, the thing that changes from question to question. So in this case, x is 3. So that is the only solution. But we're going to look at equations that have many solutions. In fact, they have infinitely many solutions. So let's say I have something like y equals 2x plus 1. Okay? So now, this equation has two variables instead of one. Other than that, it looks very similar to the first equation we looked at. So this has infinitely many solutions because x can take whatever value we like, and every time I change the value of x, there's a different value of y. So there are heaps of solutions to this equation. So we know from what I just did that I can have the solution x equals 3 and y equals 7, okay? That is a solution because if I substitute in x equals 3 and y equals 7 into this equation, then I get a true statement. So that is a solution. Remember, we always in linear functions write x first and y second. Another solution could be if I substitute x equals 6 and y equals 13. That is a solution because it makes the statement true. I could substitute in negative numbers too. If x was minus 1, then y would also be minus 1. That's another solution, and so on. There are infinitely many solutions to this equation. So instead of trying to solve it and trying to write, millions of solutions, what we do is we graph it. We show these solutions graphically. So you've probably seen this object I've just put on your screen. You've probably seen it before. This is just the Cartesian plane. So remember, the y-axis is the vertical axis and the x-axis is the horizontal axis. So what I'm going to do is I'm going to graph all the solutions to this equation up here on the Cartesian plane. Now, each of these solutions for x value and a y value is just a point that I can plot on the Cartesian plane. So I'm just going to plot the solutions that I have. So I saw that 3, 7, x equals 3, y equals 7 was a solution. So I go across, remember x always written first, I go across to 3, 3 is the x-coordinate, and I go up to 7, which is here. So that point is one of the solutions to y equals 2x plus 1. And I can do the same for the next point. I can go across to x is 6 and up to y equals 13. And I plot that point as well. And the same with the third one, minus 1, which would be down here. Now what will happen in this case, in all of these examples that we're going to do today, the points will lie in a straight line because we're doing linear functions. So what I can do is I can just join them up. So this line, and yours will be nice and beautifully ruled and all that, this line here contains infinitely many points. Each point on the line is a solution to the equation y equals 2x plus 1. So that's what the graph is. It is the set of all the solutions, all the pairs of x and y values that make the statement, make this equation true when substituted in. So that's what we're going to look at today. The table of values method is where we just draw up a table. We have our equation, we pick some x values, you choose them, and then we find the corresponding y values. So that will give us from our table, 4 or 5 solutions to the equation. We just plot them and join them up. So let's look at an example. So let's say I want to graph this equation now. I want to graph the equation y equals minus 2x plus 4. So what you do with the table of values, you draw up a table like this. So you have a row for your x and your row for your y values. Now you choose the x values. Usually it's good to choose a few negative and a few positive ones. So I'll do that. So I'll choose minus 2, minus 1, 0, 1, 2. I've chosen those x values. What I'm going to do is substitute each into this equation to find the corresponding y value. So if x is minus 2, then y would just be minus 2 times minus 2, which is x, plus 4. And that gives you 8. If x was minus 1, y would be minus 2 times minus 1 plus 4, which would give you 6. If x equals 0, y is minus 2 times 0 plus 4, which is 4. And hopefully you can see a pattern. Each time x increases by 1, y decreases by 2. And that's actually a definition of a linear function. Each time x increases by a certain amount, 1 or 2, y goes up or down by the same amount. There's always a pattern here in a linear function. So I've got now 5 columns. Each of these columns going down is a point that I can plot. So I can plot the point minus 2, 8. So minus 2, 8, I go across to x is minus 2, up to y is 8. Minus 1, 6 is there, 0, 4, and 1, 2, and 2, 0, okay? So I've got 5 points. In actual fact, if you have any 2 points on the Cartesian plane, there's only one line that will go through it. So 2 points is actually sufficient. Most people just use a few more with table of values. So I've plotted 5 points that you see in red on your screen. Each of them is a solution to this equation. So after I've plotted them, I can just join them up. So this line, just like in the last example, and I should label my line, this line, just like in the last example, is the set of all solutions to the equation y equals minus 2x plus 4. It's the set of all pairs of x and y values that when substituted into this equation make it a true statement. The last thing I have to mention is that sometimes you won't see equations written in the form y equals something. But if it's a linear function, it can be written in that form. So you might be asked to graph a line like, I don't know, 6x plus 12y equals 48, something like that, okay? Now, I can graph this the same way. I can draw up a table of values, choose x values, and find the corresponding y value. It'd be harder with this equation because each time I substitute an x value in, I have to solve an equation. I'll have to undo everything that's been done to y. So it's easiest if you get an equation like this that is not in the form y equals something. It's easiest if before you do the table of values, you rearrange it so it is in the form y equals something. So we can rearrange this equation to get y by itself. You treat this 6x just like a normal number. So in a normal equation, we'd want to get y by itself by getting this to the other side. So we're not going to do anything different just because there's an x there. So what I'm actually going to do to get this in the form I want is I'm going to subtract 6x from both sides. Remember, what you do to one side of the equation, you must do to the other. So I get 12y equals 48 minus 6x. Now, I want to undo timesing by 12, so I am going to divide each side of the equation by 12. So 12y divided by 12 gives me just y. Now, when I'm dividing this side of the equation by 12, I need to divide everything on that side by 12. So 48 divided by 12 gives me 4. Negative 6x divided by 12 gives me negative half or 0.5x. Now it is in this form, and I just do a table of values like that if I want to graph it. I won't go through that because I'm sure you get the idea now. All right, thank you for watching. This has been the luckiest maths teacher in the world. Have a great day.